Okay, Ashley, I'm going to try and go through percentages in one shot and try and make you understand what's going on with them. So, the easiest way to understand percentages is through a very simple formula. There's always some sense of time happening in a percentage problem. There is an initial amount, which is called I, so a starting amount, which has a percentage applied to it, and then that gives you a new amount or a resulting amount. So you might, initial is like before a percentage change, or an initial state, or some sort of starting value, and then n is a resulting amount, or the thing that kind of pops out the other end. So an initial amount affected by a percentage change as a multiplier equals some kind of new figure. Now that's a very simple formula to manipulate, and we can look at just how you throw the three things around in that a bit later. Well, you have to have some grasp of what a percentage change is. 100% represents a whole thing, or one thing is 100%. So a change on a percentage change on some amount is always related to a difference from 100%, or how much it's changed from its value. For example, if you increase by 5%, that would be 100 plus 5, which would be 105%. As a decimal, 1.05. To get from a decimal to a percentage, or to get from a percentage to a decimal, divide by 100, and to get from a decimal to a percentage times by 100. Multiplying or dividing by 100 is moving a decimal point 2 places. So 112% is an invisible 0.0. 112%. To turn that into a decimal, move this dot 2 places that way, you get 1.12. And so you have 0.87 as a decimal. To convert that into a percentage, multiply by 100, and you move the decimal point 2 places in the other direction, so 87%. To make this formula workable, you need to be able to interpret a decimal as a percentage, or a percentage as a decimal. Carry on with this deviation from 100. So the first one here is an increase of 5%. Let's say we've got a decrease of 11%. So an amount is decreased by 11%. That's a change of 100. So 100 take away 11, 89%. And as a decimal, 0.89. Do 4 more. An increase of 12% would be 100 plus 12, or 112%, 1.12. Decrease of 30% would be 100 minus 30, 70%. As a decimal, 0.7. You get the picture. Increase of 87%, 187, and 1.87. Okay, so far so good. Look at this formula now, and how you manipulate that formula. It's a one-step rearrangement of algebra, which is kind of the smart way of looking at it. There's a kind of an idiot-proof way of rearranging that formula, and there's kind of a more sort of sophisticated way. It's not that sophisticated, but it just means that you're able to rearrange algebraic expressions. Initial amount multiplied by a percentage equals a new amount. So usually in a percentage problem, you're trying to you're given two of these values. You're given an initial amount affected by a percentage, or you might be given an initial amount and a resultant or new amount, and you have to work out the percentage change, or you're given a percentage change on a particular item, and that gives you a new value, and you're trying to work out what the starting cost was. So one of these three things is kind of unknown. I'll give you the idiot-proof way of rearranging this. You can, without being racialist, nip. So a triangle with the word nip in it. And the way that this works, and again, just to say, this is kind of a unsophisticated way of doing it. But if you want to get n on its own, you can think of it. You cover up. Imagine covering up the n here. So n would equal the two things which are left, I times p. If you needed to know, say, an initial amount, you cover that up and you're left with n divided by p. So I is equal to n divided by p. And third way would be if you're trying to find the percentage change, so you kind of cover up the p. P is equal to n divided by I. Now when you do this on a calculator, p is always going to come out as a decimal, not as a percentage, so you need to do the conversion by moving the decimal place 2 places to the right. The kind of grown-up way of looking at rearranging this is this sentence says I multiplied by p is equal to n. If you want to get rid of a multiplication, you apply an inverse. The opposite of times is divide. So to get rid of the p, you divide both sides by p, n divided by p. And similarly, if you want to get the p on its own, what's hooked into the p is multiplied by I. So do the opposite of dividing, multiplying by I, which is dividing by I. I think really we should do some algebra first, and this is really elementary algebra. But those give you the same rearrangements as what this nip triangle thing does. So we'll just look at some practical problems. In effect, really, there are only three questions, or three kind of problems with percentages. As I just said, either initial amount needs to be calculated, the percentage change needs to be calculated, or the resulting or new amount needs to be calculated. The only other kind of problem which comes up is compound interest, which probably is more interest to you, and we can look at that. It's relatively simple. It's all simple. So I don't know. Let's say you fill your car up with 20 litres of petrol, and you drive somewhere and use 15% of the fuel. And the question is, how much fuel is remaining? Okay, so as I said, there's always some sense of time passing in a percentage problem. In this case, the initial amount is 20, so we've got I, P is equal to N. The initial amount of petrol is 20 litres. The percentage change is a decrease of 15%. Now, that would be 100% take away 15%. 100 take away 15 is 85. As a decimal, 0.85 equals new amount, or how much fuel is left. And so you get the amount of fuel left, and that's a simple multiplication, which is 17. So 17 litres is how much you've got left. So this was one where we had the new amount missing, and we're trying to calculate it. Okay, so I P is equal to N, or N I P, and okay, so a dog goes from 20 kilograms and